Hello, everyone. This is Alex Niusha Jafari, and I'm here with Erfan, and we're going to go over Chapter 3. We're starting Chapter 3 Function Follows Form. Once again, we are following from the AP Computer Science Done Right, and it is available on Amazon, and you can purchase it either as an ebook or on paper. So let's get started on Chapter 3. Erfan, are you ready?
Yes, I'm so ready and excited. Let's go.
Okay, try again. Erfan, are you ready?
Yes, I'm so ready. Let's go.
Excellent. Before we start on chapter 3, could we just quickly go over what we learned so far in chapters 1 and 2?
Sure. One and two?
Yeah, so overall,
Okay.
what we learned in, what have we learned so far before chapter 3 in general?
Yes, in chapter one, as the title shows, we learned from information to data. So we learned how to represent our information in the real world into data in the computer world. We learned about classes, we learned about the variables like int, doubles, strings, and etc. And in chapter 2, we learned about tying classes together with interface.
That's right. We did learn about tying classes together with interfaces. And we learned about why we would use interfaces and how we would also represent complex information with multiple classes as well. All right. We also learned about systematic design, if you remember. We learned about the design recipe, and that's a super important thing. So, if anyone is unsure about the design recipe, they should definitely look back to those videos again. Okay, so far so good. Should we start with chapter 3?
Let's start chapter 3 together.
Excellent. So, in this chapter, we're going to learn about representing complex attributes. So, this is the first section of our chapter 3. Now, the idea is so far, as you mentioned, we learned about how to represent numbers, and there were two different ways of representing numbers. Do you remember?
Sure, ints and doubles.
Yes, int and doubles, so only basically whole numbers and decimals. And we learned about strings, so word, and essentially that was pretty much it in terms of representing information. But there are times that it's a little bit more complex than just a number or a word. Um, let's say, uh, do you remember Elizabeth, who was going through exercises and she went to the doctor, and she went to Dr. Sarah, who is a fantastic doctor, by the way. And Dr. Sarah has a theory about a patient's typical calorie intake. So she can say, I think a person's favorite food will give me a hint of what their calorie intake is. All she has to do is multiply her favorite food's calorie by 10, and that will essentially give her the calorie intake that um, the person has on a daily basis. So, for example, if your favorite food is this, delicious chocolate bar that's about 200 calories, she multiplies it by 10 and she gets, okay, this person probably consumes about 2,000 calories per day. Does that make sense?
Yes, it does.
Excellent. Okay. So we want our software to be able to compute and represent this. So before, if you remember, I'm just going to write code in blue. We had a person class, which had a name, age, weight, and height. Which are all, a name is a string. What would you say an age is?
It's an int.
Yeah, it's an int. Weight can be an int or double. And same with the height, right?
Exactly.
Okay. So now we want to add a favorite food to the person class. So what should a favorite food type be?
I think obviously it's not a number, so the only option we're left with is a string.
Yeah, exactly. So since it's not a number, it has to be a string, right? So the problem is then we would have to like figure out how to represent that. So if, for example, your favorite food is chocolate ice cream, should the entire word of chocolate ice cream be in your favorite food string? Should it just be ice cream? The issue with this is if you just write chocolate ice cream, this calorie could range anywhere from, like, let's say, is it a whole pint? So it's like 300 calories if it's like a halo ice cream. It could be some really diet ice cream, so it's only like 100 if it's just like a scoop of it. Or it can be something like 500 because it's a smoothie or something. So you can see the issue with representing data in a string format, right?
Yes.
Okay, great. So can we represent this differently?
How can we represent it differently?
So do you remember in previous sections we talked about how to represent more complex information?
Yes, I do.
Okay. So how did we represent more complex information that couldn't be represented as strings or numbers?
We create a class for more complex information.
Yes, exactly. In a previous section, we created a class. So luckily, we have a food class. So we can say class food. It already has a name and it already has a calorie. So all we need is for a person class to kind of have a food as a favorite food. Does that make sense?
Yes, it makes sense.
Okay, so let me first write this as a UML diagram so that you understand more precisely what we want. We want a person who has a name which is of type string and a favorite food which should be of type what?
A string again?
But we just said we're going to represent complex information as classes.
Okay, so in the food class.
It wouldn't be in the food class. It's inside the person class. So the person class has a few attributes, right? The first attribute is a name, which is going to be a string. The second attribute is going to be a favorite food, and it's going to be a what?
It's going to be a food.
Yes, exactly. It's going to be of type food. So classes can be a type, essentially. And, age is an int, and all the other fields. So that's our person class. Then our food class, well, we know it has a name, and that's of type string, and it has a calorie. And what's the type there?
It's an int.
Int, exactly. And I don't believe it has anything else. And then all you're essentially saying is a person has a food. Does that make sense?
Okay, yes, it does.
Yeah, okay. So how would we code this? Well, we can write something like this. We can write class person. What are the fields of a class person?
It's a string name.
String name, exactly. What else?
It's an int age.
It will be an int age, correct. What else?
And double for weight.
Yeah, so let's pretend we had the weight and height. And then what else?
Okay. So food.
Yes. So we'll write food with a capital letter F because it's a class. So we have defined it as a capital letter food. And we just call it favorite food. And then in our constructor, we add the parameter favorite food inside the constructor. So essentially, we can now have person takes in a string name, int age, food, favorite food, and height and weight. And we just set it so that this dot favorite food gets favorite food. So far, so good?
So far, so good. Makes sense.
Excellent. And then all the other things in the constructor. So now we can have the method that we initially talked about, the potential calorie intake, which is a person's favorite food and multiplied by 10. So it's Dr. Sarah's theory. So what are the steps to creating that method? How do I create this?
So we would start with the purpose statement.
Excellent. We start with a purpose statement. What's the purpose of this method?
Let's say it's to get the potential calories intake based on their favorite food.
It doesn't get it, right? Because it's not like just a getter, so it's actually computing it, right?
Oh, sure, yes.
Yeah. So it computes this person's potential calorie intake. All right, what's the next step?
We'll start by the output. So we want to get the potential calorie intake, and I think that's an int. So we'll write int.
Mm-hmm. Yeah, so that's our signature, yeah.
Potential calorie intake, let's say the name of it.
Yep, it could be potential calorie intake as the name of the method. Okay.
Since it's a method, yes, we'll need to add parentheses.
Mm-hmm. And what's the input?
It's int calories, right?
So the calorie already exists in the person's class, right? It'll be right here. So it's just we can get that by doing this dot calorie. So we don't really need to take in anything, right?
Okay, yes.
Okay, this is a thing that has come up before, so I want to make sure we understand this so we can do more problems like this later, but it's important for us to understand when you don't need to pass in anything additionally because you have access to all the fields already. All right, what's the next step?
So we wanted to return. We use the keyword return.
Ooh, we're getting ahead of ourselves. What's the next step in the design recipe after you do the signature and the purpose statement?
Oh, we need to have an example.
Exactly. We should never forget to have an example. So our example could be, um, let's see, Irfan, you could be a person, and when I do a potential calorie intake method on you, um, let's say your favorite food is, what's your favorite food?
It's a chocolate cake, probably.
All right, chocolate cake. Um, do you know what the calorie is for the chocolate cake?
Depends on the cake, but at least I think 400 calories, maybe.
Nice. Okay, 400 calories. So if I invoke this method on you, it should return what?
400 times 10, as the doctor Sarah said, right?
Yes, exactly. So your daily calorie intake is roughly about 4,000 based on this method. Okay, well, good job there. All right. So now the next step is to code this. So how would I code this?
So we'll use the keyword return.
Yes.
This dot
This dot.
um, favorite food, I think, because then we need to add calories.
Yeah, so it will be
I
this
have I
dot.
have
Sorry, go ahead.
I had no idea if I was right or not.
That's okay. We will figure it out together. So it'll have to be this dot favorite food because this is the favorite food that you have, so chocolate cake. But to get the number of it, the favorite food has a calories. So we do another dot and we do calories. So this is accessing field of a field, essentially. And then what do we do?
And then we multiply it by 10.
Exactly. We'll multiply it by 10. And we close the parentheses because the function is done. All right. Does this make sense so far?
Yes, it makes sense.
All right. So after a lot of deliberation, Dr. Sarah tries this with a few people and then realizes, oh, your favorite food is 400 calories, but your favorite food could be like 50 calories, and that means that now your calorie intake is 500. Essentially, she realizes her theory is absolutely bogus and doesn't make any sense. So instead, she wants to understand the person's, Elizabeth's, I guess, typical breakfast, lunch, and dinner. And from there, she can assume okay, if you write down only the main food item in the meals, she can report the total calorie intake of her day. So it's not about what specific food she had for lunch, it's about the total calories of the main items. Does that make sense?
Okay, yes, it does. So generally, we wanted to get to know about a field's information inside of a field. Is that right?
Um, I'm not sure if I
Yeah, but اینجا شو کات کن.
Okay. I'm not sure if I understand the question perfectly, but so you're so we're saying she cares about breakfast, lunch, and dinner, But she doesn't care if you had eggs for breakfast and meat for lunch and pasta for dinner. What she cares about is if the main item was eggs and it was 60 calories and meat was 250 calories and pasta was 430 calories. She cares about when all of these were added together, what was your calorie intake? That's what she cares about. Does that make sense?
Okay, makes sense.
Okay. So we can represent this information several ways, right? So remember, we have a class person, and it used to have a favorite food, but we decided against that. So now instead, what could we add instead? So it has a string name. What should be added outside of name and age?
Total calorie consumption for breakfast, lunch, and dinner all together.
Right, but she doesn't know that, right? She knows her lunch, breakfast, and dinner. So instead, she could have three fields: breakfast, lunch, and dinner, and they can all potentially be of type food. And then she can add this up essentially by um, just having a calorie count of it. Or since she doesn't care about the meat, the eggs, or the pasta, these can all be just int. And Elizabeth just has to say, okay, for breakfast I had 100 calories. For lunch I had 200. For dinner I had 300, let's say, or however much she actually had. And then inside the person class, we can have a method that computes, essentially just adds all these three up together. Does that make sense?
Okay, it makes sense.
All right. Are there any questions about what we learned today, or are you good to move on to the homework? Let's just remember one thing, that the main thing that we learned today. It's when a class can have another class essentially as its field. Does that
Okay, so in that example,
Mhm.
for the favorite food example,
Yeah.
you wrote this dot favorite food dot calories. That's what this section was about, right? To access the information from another class.
Not necessarily accessing, that's part of what we learned, but the point of the class is knowing that you can now have other classes inside your class. So let's say we didn't care about the calories, we just cared about the favorite food. Like, let's say we wanted to have a method that just prints your favorite food is this, or your favorite food is, then you could do this dot favorite food. Well, essentially dot name for it. But what we care about is that you can have access to a field that is not just a string or an int or a double. It's actually a class on its
Oh,
own.
now I see. Now it makes sense.
Yeah. So it's true that we can also have access to something else inside of that, but the main thing is that we don't now have to represent classes properties by just these three things. We can actually represent it by person is now a type, food is a type. These are all different things that we could use. Make sense?
Sure, yes, it does.
Excellent. All right, in that case, let's jump to the homework section. So, the first homework I want to give you, it's about Pokemons. Are you familiar with Pokemons?
Yeah, I am familiar with them.
Oh, nice. Very good. Very good. They were quite big when I was growing up, but I think they're making a comeback. So they're mythical creatures, and they have a name, they have an age, they even have a gender, believe it or not. Um, and they have an origin, which is, an original Pokemon that they um, came from, evolved from. Does that make sense?
Okay, yes.
Pokemon. Excellent. All right. I'd like you to create a Pokemon class and instantiate it with your favorite Pokemon. And, you will essentially have to represent a class of original Pokemons, um, which for this exercise just have a name, age, and gender. Does that make sense?
Okay, yes, it does.
Excellent. All right, so that's the first problem. The second problem is regarding a global pandemic. Do you know what a pandemic is?
Yes, like Corona.
Yes, indeed. We're all so lucky enough to have lived through the pandemic as well. So, to fight a global pandemic, vaccines were developed. And some vaccines were single dose, meaning you only had to just take it once. And some vaccines were double dose. Well, actually, after a few years, there were even more. But let's just pretend that only single dose and double dose were with specified injection dates. So I'd like you to represent vaccines and add a method which returns the date when the person is fully vaccinated. So for a single dose, that would be, the first time that they get it. The double dose would be the second dose that they have. So I want this as a method. Does that all make sense?
Okay, yes, it makes sense.
Excellent. So fully vaccinated method should return the day of their final dose, essentially. All right. Well, good luck with these homeworks, Irfan. Have a wonderful day.
Thank you. You too. Bye.
Bye.